Everyone, in this video I will continue on what we have covered in the previous week, which is in week 6, where we covered how to conduct research in research methodology topic. So this week in week 7, this is supposed to be a learning video on week 7. You will learn the type of research and also how to systematically do research in order for us to get a good result. And you will learn about how your result, your presented result, can be considered as a good result or beneficial result for you to conclude that your research is something meaningful to the audience. Okay, I think we already covered everything. I mean, the flow of this research process has been covered extensively from week 1 until week 6, I believe. So I already informed you, and we already did a few exercises in defining the research problem. When you read the paper, how to extract information, how to extract where the research gap is. So we already done that. We already done a few few exercises in class where you need to read the papers and you need to extract where is the aim, what is the aim, and what is the objective of the paper, and also what are the key things that the authors want to solve, where the research gap lies in. Okay, and then you also learn. I also presented to you on how to do extensive literature review with a summary table. That I share with you. There are few types of summary table that you can use and you can utilize in your report, and we do some exercises, and you also need to submit exercises in terms of developing a good summary table, and how you, after that, we look into two types of hypotheses and how you conduct your experiment, how you conduct your research to prove your hypothesis. Okay, so we have the null hypothesis, another one, and another one is alternative hypothesis. Sorry, why is it turned to red? Let me change the color once again. Alright, so we already learned into what is the null hypothesis and what is the alternative hypothesis. So if your experiment support what you predicted before, it is considered as null hypothesis, or whether whatever finding that you found when you do experiment or you do modeling, you found that whatever your initial hypothesis is not true, then you take the alternative hypothesis. Okay, and we are currently actually in the middle of understanding how to design our research and how to collect data and how to analyze data to put it in the nice narrative, so that when the examiner and the audience read your thesis, they will understand what you try to achieve and how is your work is important and needs to be done. So we need to show actually when we are reporting something, either in a oral report where you present, or you put it in the written report, we need to show to people that there is dire problem need to be solved. So you must arrange your storyline so that it has a good narrative, and it's easy to follow, even though people are not really expert in that field. So we already covered actually how to do it from beginning to the end, but I didn't touch much on step 4 until step 8 here. So I only focus the main part here. Actually, I focus on this, how to construct literature review, how to identify gap, how to speed read, how to extract information from the article. So now we are looking into doing the experiment. So the remaining week 8 until week 14 will focus on how to do the experiment and what type of analysis can be done and how you can present the data in systematic way so that people will understand. So because sometimes students just put in the raw data, that doesn't mean anything. Okay, so when you can visualize your data into something that is more meaningful, people will appreciate it. It's easy to follow. Okay, so that's the function of putting table and also diagram in your report later on. All right, I touch a bit on the type of research I mean, in general type of research, we can divide it into these four big field, I would say. So I already explained to you guys that um, generally it is divided between qualitative and quantitative. But here I expand it a little bit more on other types of research that have been conducted worldwide. So the first one is depend on the nature of the information, whether the information that we get is the qualitative information or the quantitative information. So let's say you are collecting data from the sensor network. Okay, so you get the numbers. Perhaps you get the concentration of the air. Perhaps that is numbers. When we deal with the numbers, it is so obvious that it is quantitative research. Whereas in a qualitative research, we normally observe in terms of the quality before and after certain process has been done. So sometimes, in our engineering perspective as well, we also involve qualitative and quantitative at one go. For example, for my case, there are certain research area and certain research topic that requires us to observe the visualization of the image input and output after certain process has been done. So that is where the expert need to look whether the image or certain criteria of the image has been improved or not. And we can always support that with the quantitative analysis. Another research types, I would say, we can divide it in terms of the utility of the content or nature of subject, and method of the research, and whether it is experimental based or normally experimental based is applied based lah, applied research, or is it really a fundamental theory that you want to prove. Sometimes when it involve materials, materials engineering, for example, your research is what fundamental, because you want to understand the behavior of the certain material react when the certain additive has been added to that material, and that material perhaps used for any mechanical design, for example. So that kind of project is actually a basic research, and it involve a fundamental how the material strength, how the young modulus of the material really affect the performance of the whole system. Okay, so and there's another topic that involve applied research, meaning that the foundation of the theory has been known, how it react has been known, but the application, how it behave, different in terms of different application. Okay, so that can be considered as applied research. For example, computer aided diagnosis is quite, I put it here. Computer aided diagnosis is widely available. So many people have done it, but this computer aided diagnosis has so many applications, and each application will give different perspective and different problems to be solved. Okay, so due to that, it get different problem to be solved, different problem to be solved. Okay, so since it has different problems to be solved, we need to do certain criteria, certain tuning on the criteria that we are investigated on. All right, so perhaps the computer aided diagnosis in certain aspect has not been covered yet. So although the computer aided diagnosis, how it behaves, the fundamental theory behind computer aided diagnosis is well known, but in certain aspect it is still new. A certain aspect is still not being covered yet. So that can be considered as applied research. All right. So there's a second type of research that we can divide on. Another way to divide the type of research is through how we approach the research, how we approach the research in terms of how we want to design it. Okay, whether your research is longitudinal, or cross-sectional research. Okay, so longitudinal meaning that you study about certain factors and you reflect it with comparison it with previous years, okay, or previous behavior in certain amount of time. Sorry. For that, I continue here. So, as I mentioned just now, longitudinal study follow the same group, and you study it over a period of time. Okay, so it's the same sample, same sample that you follow. You study their behavior and how it changes over time. And the cross-sectional area involve looking at data. Okay, wait, I put it here. Looking at data from a population, over a certain period of time. So it could be in that population, it could be multiple group inside it. Okay, but in longitudinal research, it must be the same sample. Perhaps you are investigating like 10 person from how their BMI changed from year 2010 until 2020. It's the same 10%. But cross-sectional area, you are looking at BMI, changes of BMI over 10 years time in Kuala Lumpur, perhaps. So people in Kuala Lumpur changes. I mean, like over the years, there will be increases. There will be a newborn and also death coming in and out. Okay, so you are looking into a population over the time, but it can be not the same person. But longitudinal study, you are dealing with the same person and you want to see their behavior, you want to see the changes of that person over time. So it involves in not just medical. Sometimes in I got few friends from sports science, sports science center. They want to study how one athlete change in their behavior after long training of 10 months training, perhaps. So it's the same athlete, and they observe it from month 1 until month 10. All right. Another type of research that we can divide into when we look into method of handling the research, method of doing the research, whether it is survey research, whether it is philosophical research or historical research, that you look into previous data. Okay, so the survey research also normally we accompany it with the statistical analysis. Right. Okay. So on the basis of the information, when we want to divide the research on the basis of information, we normally divide whether it is qualitative or quantitative. And if you want to decide, divide the research in terms of the nature or method of the research, we always say that whether it's a fundamental research or it's applied research. So for example, in engineering, when I said that we normally do quantitative research, people assume that everyone do a quantitative research. And we don't longer ask whether your nature of research, whether it's qualitative or quantitative. We normally jump into, okay, we assume everyone is doing quantitative or combination of both. Nobody do it qualitative only because we are in engineering faculty. But we always ask whether the research is fundamental type or applied type. And for certain project, some project require us to understand whether how you approach the research, whether it is longitudinal or cross-sectional. And on the basis of the research, and philosophical research means it's purely qualitative in nature, and we are focusing on the vision of others on the content of the research. Historical research is both qualitative and quantitative in nature and deals with the past event. Normally, when we do historical research, is always involved with retrospective data lah. Meaning that data that is available from the past. And survey research normally present an event, and it is quantitative in nature, and it may be subdivided into correlational study or discretional study, exploratory, and so on. Okay, so the experiment type will be, of course, will involve quantitative in nature, and you can directly, or what we call, you can directly get a data directly from the experiment or modeling that you've done. So when you do experimental research normally, when it involves data, this is where I said how you present the data, how you conduct the experiment, why you conduct that step of experiment will will show whether you are really understand the topic and why the step that you have done in your research, in your experimental research, is important to be done. Okay. And the study research deals with unusual event. It may be qualitative, it may be quantitative. What I can see from the trend so far right now, the study research that we are dealing right now is a pandemic time. It's a seasonal. Before COVID-19, another seasonal topic that kind of famous, landslide, that one kind of famous. It's seasonal. If you see, okay, I mean, nearing raining season, you will see a lot of news on the landslide and so on. And if there is grand opening at that time, people who are proposing projects on landslide will attract examiners' attention, or flood. So that's another seasonal topic that people will pick up. Flood is something that always happen in Malaysia, but yet the problem is still, I mean, the problem is still exists, and still a lot to be solved. Not just how to manage the flood, but also in terms of the another risk associated with the flood. Okay, there's plenty of problem statement can come out from the flood. So that's kind of seasonal project that people are take up, but interesting to be done. So now it's COVID lah, because we are in the infectious disease era of pandemic now. So this is kind of popular. If you search a paper on COVID, there will plenty of paper that try researchers try to do something beneficial in combating this COVID-19. Okay.
Now let's look at the basic versus applied research. Actually, some book use basic, but I normally use basic also correct. Not to say wrong, but I normally use the word fundamental.
Because sometimes when we say basic research, people will say that the research is easy to be done. But that's not the case. So I normally use the term fundamental research. So some book use basic research. So I divide it in terms of a few criteria here, which is the purpose of doing research, nature of the research, usage, concern with, and also the main goal of conducting that research. So let's look at the fundamental research. So fundamental research aim at expanding existing base of scientific knowledge. So that's why I said I give example just now about materials engineering. I think most of you will involve in this kind of project later on, especially in mechanical department student. The behavior of the materials depends on what additive have been put in on that material. So you always want the material that is light, but also have a good mechanical strength, and other more. And that's not my field. I don't really know that. But there's certain aspect that you need to tune in order for you to make sure that, okay, if you tweak or if you increase this portion, the other performance of the material will decrease and so on. So there's always contradicting and conflicting requirement when we involve with the materials engineering. So the basic of how the material behave, we know. So let's say like material that has lower Young modulus, what will happen to the strength and so on. But the basic we know. But then when the material being combined with another type of additive, it will turn into something else and the behavior will be different. Okay, so we aim to expand the basic knowledge of the how material behave in mechanics of material topic. And normally fundamental involve, as I said just now, is involved in the theoretical. And in terms of usage, is a bit universal. Because you want to prove a theory, so it can be easily expanded to something else. It's a bit universal in terms of the usage of the fundamental research. And we are developing scientific knowledge and prediction, and the main goal is to add knowledge to the existing one. Whereas when you are dealing with applied research, we want to solve a specific practical problem, and it always the nature of it is always a practical case. And the usage is a bit limited because we are solving one specific problem, and this solution it fantastically solve for one problem, but it may not be the same case for the other problem. So the applied research sometimes this is the is a bit the lacking in terms of applied research. Sometimes whatever that we found out and the finding that we found out in the applied research it only work in certain cases. Meaning in your problem, it may not work for the other type of research. Okay, and what does it mean between primary and secondary? Later we will look into what does it mean by primary data and secondary data. So the primary research involved in dealing with primary data, meaning that you obtain first-hand data or information. You are the one who go and collect the data. So let's say you are doing survey research, you are the one who conducted the survey, you are the one who constructed the survey, you are the one distributed the survey, and you are the one who analyzed the survey. That could be that is considered as primary data. Or you go to the lab, you tweak certain parameter, and you see what happened to that material perhaps, or you change the behavior of certain parameter and you see what happened to your sample. So the one that you do in the lab directly, you are the one who collect the data. So you are the first one, the first responder who get the data, that is considered as primary research because you're relying on the primary data. Okay, and it is normally done by researchers. The one who collect the data, it must be the one who needed to use the data. So if you are a company collecting some data, there must be something going on. For what? You collect the data, there must be something need to be done to the data in order for the experiment to be conducted. So normally the researcher involved in collecting the data, or in a certain company, R&D department will always collecting the data, or risk management company will always collecting the data, who are involved and interested in this type of data. And it concerned with specific to the research need and requirement, and it involve high cost, and sometimes involve cost that is quite high, and normally it's long. Sometimes when you do research, 1 year has been taken up by collecting data only. So of course it's good to have a primary data because you are the one who go and collect the data and you get the sample and so on. But again, it requires a lot of time and a lot of resources. But we are in 2021. There's so many people have doing the research, and now the sharing data, data sharing has become culture in our research world. Even Malaysia also start to share the data. Not sensitive data. The data that can be exploited and used by other researcher or by other person who are dealing with the specific topic. So the secondary data, we analyze and interpret the information obtained from primary research, meaning that there's another people who collect the data, they put it in the database, public database, and you can collect the data and it is readily available. So have you heard about GitHub? So if you go to GitHub or Kaggle, there's a lot of available and free data. If you involve image processing, there's a lot of images out there. So let's say you are developing one object tracking algorithm to detect cars on the highway. There's available video on that. The CCTV video of car moving on highway. And if you are dealing with medical image data as well, there's a lot of images that available, CT scan, mammogram, MRI, and so on. So now it has become a culture for the researcher. When we get the data, we share it with others. Of course, with the consent from the patient, but then this data can be utilized by other person in the country to understand certain problem. So like for COVID, if you search on internet, there's a COVID CT scan images, COVID X-ray, chest X-ray images that is available, that are available for us to extract it. Even KKM now, Ministry of Health, our Ministry of Health now start to share the data. If you go to our I mean any GitHub, KKM GitHub, they already put in number of cases, perhaps what else that I saw few times, few days ago. Percentage of and cases of sorry, COVID-19 immunization and so on. So there's a lot of secondary data that is available in public database. You can have a look at it. And if you're involved in she student, you are involved in occupational injury and so on. So there's actually data available on OSHA, sorry, occupational safety in America, OSHA website. You can have a look at it. They are publicly available. And the data is quite extensive. For each patient, they already state what type of injury they got from the industry sector, and not just that, the BMI of the patient, the age of the patient, and so on. It's quite extensive, and you can get it. For data researcher like me, the one who did AI and machine learning, we are relying on the secondary data. If you want to collect the data that only develop the predictive algorithm, it will take longer time. So we always collaborate with our another counterpart, which is Singapore Hospital. They are the one who collecting the data directly, meaning the doctor at the hospital, because the patient goes there. So they are the one who directly collect the data, but we are the one exploiting whatever that has been collected from the hospital. Okay. And it may and may not be specific to the research requirement, and the cost is low and the time obviously is short. You just can download it. However, the disadvantage of secondary data is you are relying on the data that people have put. So if you want something that is so specific to your application, it may not be available. Because you have to follow whatever people have, uploaded first. So if you want something that is so specific, perhaps the data is not available, the secondary data is not available, you have to do it on your own and collect it and do a primary research in this context. Okay. So what exactly research design? Research design is conceptual structure and research activity. Most importantly, we want to achieve whatever that we state in the objective. And you must remember, objective drive the method. That's why it is important for you to really understand what you want to do. Then only you know what experiment you want to conduct. You want to be conducted. Okay. So when you know what objective or what are the things that you want to do, you can construct what methods in order for you to achieve that objective. And when that thing happen, you will think about, okay, what are the tools that I need to use in order for me to conduct the experiment. Okay, so it goes in that flow. That is why in your report also it goes in that flow, meaning that first your chapter 1 will deal on objective and method, and aim, and then it goes method, then chapter 4 will go on results. So that's why it is structured that way. So the objective will need to be tabulated in order for you to determine what are the methods suitable for your research. And you must check also whether the procedure of getting whatever that you want or to achieve your objective, whether it is in sequence or combination in which these tools and techniques are applied. Okay? And research design also include planning of the research activity, and then tabulate what are the techniques that you want to use, and if it is involved collecting data, what method to use, whether you need to decide although whether it is a primary or secondary data, and when you get the data, how you want to present the data so that it become meaningful, it becomes something that is meaningful. And this meaningful data is important for you to show that the impact or the outcome of the research. Right? Then only the final design will be, the final output will be you design a prototype or system architecture um, in order for you to solve the specific problem that you mentioned in your objective. Okay. Okay, significance of a good research design. Why it is so significant for us to have a good research design? Number one, it is provide the direction of the research work, allow for systematic execution. When you don't know what you want to do from beginning, you will fail to design your experiment, and your experiment later on will conclude something else than what you predicted earlier on. Okay, and where you have a good research design, you will know where to adjust your objective and how to minimize your scope. We don't want to do something that is too big until we cannot see the whole storyline. Okay, so the bigger picture must be there in order for you to wrap up your report, because you only do it in 2 semesters. And a good research design also will determine um, whether you have a good plan of conducting the experiment with a good plan of using the resources. If you do it everything just try and error, you may waste your time, you may waste your money, because you do unnecessary thing. Okay, and we also could identify possible pitfall or problem in advance and anticipate it for remedy way before we start the experiment. And we also want, the most important thing, whatever that we are doing, we must show that there is a little bit contribution or novelty in our design. So we don't want to duplicate what people have done, and provide means to estimate research duration. Okay, and these are the consideration that you need to think of when you conducting design. I mean, you design research activities. What to consider? Number one, purpose of each activity. Whether your method, the step of in your methodology, really addressing the objective that you want to achieve. Okay, and what is the time frame here? I always ask the student. I always ask my student, okay, you want to do this, how long do you think you need it? 1 week, 2 weeks, or 3 weeks? If the student come up with like, I'm not so sure, doctor. And so I know that, I mean, we will be in trouble, because the student really don't know how lengthy the work is, how short the work is. Meaning that the student don't really understand what needs to be done. So that is where I always tackle, okay, I think you didn't clear on what you need to do. Do you really know what you want to do? I will start brainstorm once again. Okay, because we need to break our tasks individually in a small portion, so that you know that you already achieved the objective. That's the most important thing. And facilities. There's no way of conducting something or proposing to conduct something that is so fantastic, but there's no major equipment, there's no tools that can be used within your working area and also the faculty resources. And if it's involved cost, financial, do you have financial support to cover it? Some of your lecturers, most of your lecturers actually, they have research grant, so that's why sometimes their project is a bit narrowed down to the research, to the research that they are doing so far. So you need to check on that, whether whatever that you are proposing, whether it is within the scope of the research that your supervisor are working so far, and is there any financial support to cover for your experiment later on. And you must make sure when you pick the supervisor, obviously you need to pick the one who are expert in that field lah. Because the technical support, if you don't have it from your supervisor, and later you don't have the technical support and so from the technician in the lab, you will have trouble to even start. So that's make it even difficult for you, and you will dreading yourself to start the experiment. And you may want to use your strength to your advantage. That is why I always say, the one who are working in industry, pick topics that your company are doing it. You are the one who get the data directly from the company, and your company vision is solving that problem. That would be great. So you don't do two things. Because you don't really have time. You only have weekend. The rest of the weekdays you are working. So be smart on selecting the research topic. Okay. I saw in the some of you already submitted the research proposal assignment. I saw some of it really take up the problem statement coming from their company. That's good. It shows that you understand, and it shows that you know how to transfer whatever that you have learned in the class to the um, direct setting of industry setting. Okay, how to start now? All right. Start with a good niche area. Because we want to highlight your contribution. Although it is small, we need to highlight it. So we need to find a good niche area. And after that, we need to formulate general methodology, whether it is primary research or it is secondary research. You need to define that first. If it's secondary research, until the data you collect from which year until which year, what type of data, so you need to define that first. Okay. And if you are collecting data on your own, meaning that your research is primary research, you need to have some general outline what you need to do throughout your 2 semesters in order for you to complete your attain your objective. After you have a general outline of what you need to do in the methodology, now is the time for you to define what are the parameters, what are the factors affecting your study, factors affecting your study. Okay, this is where also you need to be careful with your scope. Don't do something that is too bombastic, but then it is not within 2 semesters. And after that, you need to define suitable data collection and analysis method, and you have to have in mind what is the expected result that you are looking at. If you don't know, because you don't know from beginning, you don't know whether the materials behave in certain way, you have no idea at all. So it will become, like there's no direction of your research. You don't know whether whatever result that you get, whether it's correct or not. Whether this is something that you want or not. So that's why narrow it down your method to achieve your objective. So I always, let's say, for your master by coursework, you have objective 1 and objective 2. Normally it's until 3 objectives. Don't do more than that because it's too lengthy later on. Maximum 3, minimum 2 like that. So 2 is enough actually. So this first objective, second objective, what are the methods that you need to conduct in order for you to achieve this? You must always reflect back. Okay, so what are the techniques that you conduct here in order for you to achieve this? If your method, whatever that you are doing right now, does not really address the objective, reflect back whether your objective is too broad or your objective that you plot before is not really a good objective. So it should be here to here, the direction. Objective, you set the objective, a good objective, then you can set what are the methods that you want to use. But if you're doing whatever that you are doing right now in the methodology, and you found that whatever that you do don't really answer objective 1 or objective 2 that you stated before, meaning that there's some way whatever that you are doing is a bit wrong. Your approach is a bit wrong. So I always, before submitting, always look back on this, whether your method can reflect on the objective that you state. Sometimes the student like to put very bombastic objective, but then the method do something else. It shows how shallow the research is, So when you don't really define clearly the objective and the method are not in line, it shows that you are shallow in doing research. You see, you don't really fulfill whatever that you claim. Padahal you already done so much. We don't want that. We don't want the examiner to have that kind of impression. Right? Broad type. This is just a recap. The broad type of research is always qualitative and quantitative. In our faculty, we always have quantitative or combination of both. I rarely see qualitative only. I rarely see that. It always involves the combination of both And the qualitative research, again, it depends on the narrative, subject or words, and summarized behavior, and involve interview, focus group discussion, survey, observation notes, and so on. Okay. We are dealing more on the quantitative, where we collect numerical data and analyze it we explore the relationship between variable, the independent and dependent variable, okay, and we analyze what will happen to this dependent variable if we change the behavior of independent variable, and it is normally in terms of experimental or quasi-experimental, okay. So what's the difference between experimental and quasi-experimental? Experimental design characterized by complete random assignment of group or subject, and group are independent and we usually employ strong control environment. Whereas quasi-experimental design, a group or subject not randomly assigned, meaning that you select you select the sample and may not have a comparison group. Typically, in the clinical research, within subject repeated measure, and it is less subject intensive lah. Tools for executing the research. Measurement characteristic. Before that, let's look at what it is. What are the criteria? What are the characteristic of a good measurement? Measurement during experimentation, before we start conducting experiment, this is the most important thing. What is the baseline performance? What is the in image processing, we always say this. What is the ground truth here? That being said by the clinician. What is the ground truth? When you say that this mammogram image, there's a lesion, this is breast cancer. How do you know that this is really lesion for breast cancer? So there must be a ground truth that doctor already defined that, and we can compare it. Okay, and if you're doing experiment, you must have one baseline when in the control environment, how the materials behave, for example. And you must be able to identify what is the input and output of the variable. If you are doing AI, I always ask my student, okay, you want to do something fantastic AI, ramai sangat tengok cerita Iron Man, people over glorify AI. AI is not something magic like God. No. We need to define what is the input, what is the output here. How many layers inside here? So what is the input here and what is the output here? What do you want? And what are the features that you insert in? Okay, we need to define that. And from that, after we define what is input and output, then we check whether the data is available or not. If data is not available, we need to collect it, and how the sampling techniques that we're going to use. For example, the one who involve water quality sampling. If you what kind of sampling techniques that you use, and whether you are taking the sample at the same time, is it effect or not? Let's say you want to take water quality at Varsity Lake. Water quality in the morning and water quality in the evening, of course, is different. So you have to set the right time at every day, meaning that when you collect the data, it must be at the same time. And where to collect the data or sample, and what is the frequency or sample size. And you need to establish operational definition. Determine the current performance and performance standard, as I said, the ground truth just now. And we need to be able to verify our measurement method with data that research that been published before, and also with the theory. Okay, theory and also published work. Okay. So in terms of measurement system analysis, there are 4 characteristics to examine whether whatever that you design, your system, it is good or not. We tell in terms of sensitivity, reproducibility, repeatability, and also accuracy. So sensitivity, what does it mean by each and every measurement here? Sensitivity means instrument should be sensitive enough to detect differences in measurement as like as 1/10 of total tolerance specification. For example, I relate it with our current situation. Our saliva COVID test. It is very sensitive. You can take from the saliva you don't need the last sample. You just take saliva. You can the test is sensitive enough to detect whether you have COVID or not. And the most important thing, whether your data is or your result is reliable or not, whether it can be reproduced. Reproduce measurement. Okay, so you need to check whatever that you get is comparable with others, comparable with other instrument or comparable with whatever people have published before. And accuracy, how close to an unbiased true value. Difference between average of a number of measurement and true value. For example, we check a micrometer with a gauge block and relate to systematic error. And precision is how close the measurement between each other. And ability to repeat same measurement by same operator at the same time. Lack of precision will refer to as random error. And to improve the accuracy and precision, we must have a defined test method and must be statistically stable. Okay. So this is what it means by precise but not accurate. Precise means they are together. The data that you get, they are close to each other. Close to each other, but may not be close to the objective that we want. Okay. Accurate means that your result is close to ground truth, close to the objective that you want. Okay. Okay. For this case, it is close to the center here. But it's okay. This is the goal here, the ground truth here, ground truth here. So the data here is very close to the goal, but it is not precise. Here, data is not accurate, but they are precise. Sorry, not accurate and not precise. This one is precise but not accurate. This one is neither that. They are far from each other, and also they are far from the ground truth here. Here is accurate and precise. This is what we want. We always want in our system lah, where the data is close to each other and very close to the ground truth. Alright. So this is the probability density and the value. Okay, and this is what we call the precision. We don't want this graph to be, the precision becomes too big. Like you have like this graph, the precision is too big. We don't want that. And how accurate to the ground truth. That's the most important thing. If experiment contains systematic error, increasing sample size will increase precision, but does not really improve accuracy. And eliminating systematic error will improve accuracy, but does not change the precision. Okay. So when you want to present your data, these are the factors that you want to consider. Whether your data is, we want to show that our data is accurate and precise lah. That's number one. But if it's not accurate, slightly accurate, but then it is precise, it's considered good enough. Because we hardly get accurate and precise normally. We hardly get that. We always get something. We hope that we get something like this, but then it's a bit nearer to the to our goal. Okay, all right. Okay, I stop the learning video here. I will continue in the week 8 class on research design. Okay, thank you.